I am a visionary. Illuminating galaxies to witness the birth of stars. And sharpening our understanding of extreme weather events. I am a helper, guiding the blind through a crowded world.
I was thinking about running to the store.
And giving voice to those who cannot speak.
Do not make me laugh.
I am a transformer, harnessing gravity to store renewable power. And paving the way towards unlimited clean energy for us all. I am a trainer, teaching robots to assist, to watch out for danger, and help save lives. I am a healer, providing a new generation of cures and new levels of patient care.
Doctor, that I am allergic to penicillin. Is it still okay to take the medications?
Definitely. These antibiotics don't contain penicillin, so it's perfectly safe for you to take them.
I am a navigator, generating virtual scenarios to let us safely explore the real world and understand every decision. I even helped write the script. Breathe life into the words en muchos idiomas y escribí la música. I am AI, brought to life by Nvidia, deep learning, and brilliant minds everywhere.
Welcome to GTC. This conference is represented by some amazing companies. This list, this is not the attendees. These are the presenters. This is what's amazing. These are the presenters of the non-IT industries using accelerated computing to solve problems that normal computers can't. But how did we start? How did we get here? I made a little cartoon for you. Literally, I drew this. In one page, this is NVIDIA's journey. Started in 1993. This might be the rest of the talk. 1993, this is our journey. We were founded in 1993. There are several important events that happened along the way. I'll just highlight a few. In 2006, CUDA, which has turned out to have been a revolutionary computing model, we thought it was revolutionary then. It was going to be an overnight success, and almost 20 years later, it happened. In 2012, AlexNet, AI and CUDA made first contact. In 2016, recognizing the importance of this computing model, we invented a brand new type of computer. We called it DGX-1. 170 teraflops in this supercomputer. 8 GPUs connected together for the very first time. I hand-delivered the very first DGX-1 to a startup located in San Francisco called OpenAI. Blackwell is not a chip. Blackwell is the name of a platform. This is the most advanced GPU in the world in production today. This is Hopper. Hopper changed the world. This is Blackwell. 208 billion transistors, and so you could see, I can see, there's a small line between two dies. This is the first time two dies have abutted like this together in such a way that the two dies think it's one chip. There's 10 terabytes of data between it, 10 terabytes per second, so that these two sides of the Blackwell chip have no clue which side they're on. There's no memory locality issues, no cache issues. It's just one giant chip. And so when we were told that Blackwell's ambitions were beyond the limits of physics, the engineer said, so what? And so this is what happened. And so this is the Blackwell chip, and it goes into two types of systems. The first one is form-fit-function compatible to Hopper. And so you slide on Hopper and you push in Blackwell. That's the reason why one of the challenges of ramping is going to be so efficient. In the middle, in the heydays of the PC revolution, 100 times every 10 years. In the last 8 years, we've gone 1,000 times. We have 2 more years to go. The rate at which we're advancing computing is insane, and it's still not fast enough, so we built another chip. This chip is just an incredible chip. We call it the NVLink switch. It's 50 billion transistors. It's almost the size of Hopper all by itself. This switch chip has 4 NVLinks in it, each 1.8 terabytes per second, and it has computation in it, as I mentioned. What is this chip for? If we were to build such a chip, we can have every single GPU talk to every other GPU at full speed at the same time. That's insane. In the future, data centers are going to be thought of, as I mentioned earlier, as an AI factory.
To meet the demand for NVIDIA accelerated computing, Wistron, one of our leading manufacturing partners, is building digital twins of NVIDIA DGX and HGX factories using custom software developed with Omniverse SDKs and APIs. For their newest factory, Wistron started with a digital twin to virtually integrate their multi-CAD and process simulation data into a unified view. Testing and optimizing layouts in this physically accurate digital environment increased worker efficiency by 51%. During construction, the Omniverse digital twin was used to verify that the physical build matched the digital plans. Identifying any discrepancies early has helped avoid costly change orders. And the results have been impressive. Using a digital twin helped bring Wistron's factory online in half the time, just 2.5 months instead of 5. In operation, the Omniverse digital twin helps Wistron rapidly test new layouts to accommodate new processes or improve operations in the existing space, and monitor real-time operations using live IoT data from every machine on the production line, which ultimately enabled Wistron to reduce end-to-end cycle times by 50% and defect rates by 40%.
Years later, where we recognize text, we recognize images, we recognize videos and sounds and images. Not only do we recognize them, we understand their meaning. We understand the meaning of the text. That's the reason why I can chat with you. If you can understand these things, what else can you understand that you've digitized? The reason why we started with text and images is because we digitized those. But what else have we digitized? Well, it turns out we've digitized a lot of things. Proteins and genes and brain waves. Anything you can digitize, so long as there's structure, we can probably learn some patterns from it. And if we can learn the patterns from it, we can understand its meaning. If we can understand its meaning, we might be able to generate it as well. And so therefore, the generative AI revolution is here. And so we're creating Earth 2, a digital twin of the Earth for predicting weather.
As the Earth's climate changes, AI-powered weather forecasting is allowing us to more accurately predict and track severe storms. Using CorDiff, Extreme events like Chanthu can be super resolved from 25 km to 2 km resolution, with 1,000 times the speed and 3,000 times the energy efficiency of conventional weather models.
NVIDIA Healthcare, something we started 15 years ago. We're super excited about this. This is an area where we're very, very proud.
Virtual screening for new medicines is a computationally intractable problem. Existing techniques can only scan billions of compounds and require days on thousands of standard compute nodes to identify new drug candidates. NVIDIA BioNeMo NIMs enable a new generative screening paradigm. Using NIMs for protein structure prediction with AlphaFold, molecule generation with MolMIM, and docking with DiffDock, we can now generate and screen candidate molecules in a matter of minutes. MolMIM can connect to custom applications to steer the generative process, iteratively optimizing for desired properties. These applications can be defined with BioNeMo microservices or built from scratch. Here, a physics-based simulation optimizes for a molecule's ability to bind to a target protein, while optimizing for other favorable molecular properties in parallel. MolMIM generates high-quality drug-like molecules that bind to the target and are synthesizable, translating to a higher probability of developing successful medicines faster. BioNeMo is enabling a new paradigm in drug discovery with NIMs, providing on-demand microservices that can be combined to build powerful drug discovery workflows like de novo protein design or guided molecule generation for virtual screening. BioNeMo NIMs are helping researchers and developers reinvent computational drug design.
A NIM. It's a pre-trained model, so it's pretty clever. And it is packaged and optimized to run across NVIDIA's installed base, which is very, very large. What's inside it is incredible. You have all these pre-trained, state-of-the-art open source models. They could be open source, they could be from one of our partners, it could be created by us, like NVIDIA MolMIM. It is packaged up with all of its dependencies. So CUDA, the right version, cuDNN, the right version, TensorRT, LLM, distributing across the multiple GPUs, Triton Inference Server, all completely packaged together. It's optimized, depending on whether you have a single GPU, multi-GPU, or multi-node of GPUs, it's optimized for that. And it's connected up with APIs that are simple to use. Now think about what an AI API is. An AI API is an interface that you just talk to. And so this is a piece of software in the future that has a really simple API, and that API is called human. And that's the way software is going to be built someday. How do we build software in the future? It is unlikely that you'll write it from scratch or write a whole bunch of Python code or anything like that. It is very likely that you assemble a team of AIs. There's probably going to be a super AI that you use that takes the mission that you give it and breaks it down into an execution plan. Some of that execution plan could be handed off to another NIM. That NIM would maybe understand SAP. The language of SAP is ABAP. It might understand ServiceNow. And it go retrieve some information from their platforms. It might then hand that result to another NIM who goes off and does some calculation on it. Maybe it's an optimization software, a combinatorial optimization algorithm. Maybe it's just some basic calculator. Maybe it's pandas to do some numerical analysis on it. And then it comes back with its answer, and it gets combined with everybody else's, and because it's been presented with this is what the right answer should look like, it knows what right answers to produce, and it presents it to you. We can get a report every single day at top of the hour that has something to do with a build plan or some forecast or some customer alert or some bugs database or whatever it happens to be, and we could assemble it using all these NIMs. And because that NVIDIA AI Foundry is working with some of the world's great companies. SAP generates 87% of the world's global commerce. Basically, the world runs on SAP. We run on SAP. NVIDIA and SAP are building SAP Joule co-pilots using NVIDIA NeMo and DGX Cloud. ServiceNow, they run 85% of the world's Fortune 500 companies run their people and customer service operations on ServiceNow. And they're using NVIDIA AI Foundry to build ServiceNow Assist virtual assistants. Cohesity backs up the world's data. They're sitting on a gold mine of data. Hundreds of exabytes of data, over 10,000 companies. NVIDIA AI Foundry is working with them, helping them build their Gaia generative AI agent. Snowflake is a company that stores the world's digital warehouse in the cloud and serves over 3 billion queries a day for 10,000 enterprise customers. Snowflake is working with NVIDIA AI Foundry to build copilots with NVIDIA NeMo and NIMS. NetApp, nearly half of the files in the world are stored on-prem on NetApp. NVIDIA AI Foundry is helping them build chatbots and copilots like those vector databases and retrievers with NVIDIA NeMo and NIMS. And we have a great partnership with Dell. Everybody who is building these chatbots and generative AI, when you're ready to run it, you're going to need an AI factory. And nobody is better at building end-to-end systems of very large scale for the enterprise than Dell. And so anybody, any company, every company will need to build AI factories. And it turns out that Michael is here. He's happy to take your order. To the laws of physics. And so we need a simulation engine that represents the world digitally for the robot, so that the robot has a gym to go learn how to be a robot. We call that virtual world Omniverse. And the computer that runs Omniverse is called OVX. And OVX, the computer itself, is hosted in the Azure cloud. Okay? And so basically, we built these three things, these three systems. On top of it, we have algorithms for every single one. Now, I'm going to show you one super example of how AI and Omniverse are going to work together. The example I'm going to show you is kind of insane, but it's going to be very, very close to tomorrow. It's a robotics building. This robotics building is called a warehouse. Inside the robotics building are going to be some autonomous systems. Some of the autonomous systems are going to be called humans, and some of the autonomous systems are going to be called forklifts. And these autonomous systems are going to interact with each other, of course, autonomously, and it's going to be overlooked upon by this warehouse to keep everybody out of harm's way. The warehouse is essentially an air traffic controller, and whenever it sees something happening, it will redirect traffic and give new waypoints, just new waypoints to the robots and the people, and they'll know exactly what to do. This warehouse, this building, you can also talk to. Of course you could talk to it. Hey, SAP Center, how are you feeling today?
Of heavy industries starts as a digital twin. The AI agents helping robots, workers, and infrastructure navigate unpredictable events in complex industrial spaces will be built and evaluated first in sophisticated digital twins. This Omniverse digital twin of a 100,000 square foot warehouse is operating as a simulation environment that integrates digital workers, AMRs running the NVIDIA Isaac Perceptor stack, centralized activity maps of the entire warehouse from 100 simulated ceiling mount cameras using NVIDIA Metropolis, and AMR route planning with NVIDIA cuOpt. Software-in-loop testing of AI agents in this physically accurate simulated environment enables us to evaluate and refine how the system adapts to real-world unpredictability. Here, an incident occurs along this AMR's planned route, blocking its path as it moves to pick up a pallet. NVIDIA Metropolis updates and sends a real-time occupancy map to cuOpt, where a new optimal route is calculated. The AMR is enabled to see around corners and improve its mission efficiency. With generative AI-powered Metropolis Vision Foundation models, operators can even ask questions using natural language. The visual model understands nuanced activity and can offer immediate insights to improve operations. All of the sensor data is created in simulation and passed to the real-time AI, running as NVIDIA Inference Microservices, or NIMS. And when the AI is ready to be deployed in the physical twin, the real warehouse, we connect Metropolis and Isaac NIMS to real sensors with the ability for continuous improvement of both the digital twin and the AI models.
Deliver products at scale. Now we are bringing the real and the digital worlds even closer by integrating NVIDIA AI and Omniverse technologies into Teamcenter X. Omniverse APIs enable data interoperability and physics-based rendering to industrial-scale design and manufacturing projects. Our customers, Hyundai, market leader in sustainable ship manufacturing, builds ammonia and hydrogen-powered ships, often comprising over 7 million discrete parts. With Omniverse APIs, Teamcenter X lets companies like Hyundai unify and visualize these massive engineering data sets interactively and integrate generative AI to generate 3D objects or HDRI backgrounds to see their projects in context. The result, an ultra-intuitive, photoreal, physics-based digital twin that eliminates waste and errors, delivering huge savings in cost and time. And we are building this for collaboration, whether across more Siemens accelerator tools like Siemens NX or Star CCM+, or across teams working on their favorite.
We create smarter and faster. We push it to fail so it can learn. We teach it, then help it teach itself. We broaden its understanding to take on new challenges with absolute precision and succeed. We make it perceive and move and even reason so it can share our world with us. This is where inspiration leads us, the next frontier. This is NVIDIA Project Groot. A general-purpose foundation model for humanoid robot learning. The Groot model takes multimodal instructions and past interactions as input and produces the next action for the robot to execute. We developed Isaac Lab, a robot learning application to train Groot on Omniverse Isaac Sim. And we scale out with Osmo, a new compute orchestration service that coordinates workflows across DGX systems for training and OVX systems for simulation. With these tools, we can train Groot in physically based simulation and transfer zero shot to the real world. The Groot model will enable a robot to learn from a handful of human demonstrations, so it can help with everyday tasks and emulate human movement just by observing us. This is made possible with NVIDIA's technologies that can understand humans from videos, train models in simulation, and ultimately deploy them directly to physical robots. Connecting Groot to a large language model even allows it to generate motions by following natural language instructions.
Hi, GL1. Can you give me a high five?
Sure thing. Let's high five.
Can you give us some cool moves?
Sure. Check this out.
All this incredible intelligence is powered by the new Jensen Thor robotics chips, designed for Groot, built for the future. With Isaac Lab, Osmo, and Groot, we're providing the building blocks for the next generation of AI-powered robotics.
Little Jetson robotics computers inside. They learn to walk in Isaac Sim. Ladies and gentlemen, this is orange, and this is the famous green. They are the BDX robots of Disney. Amazing Disney research. Data centers should be accelerated. $1 trillion worth of installed data centers will become modernized over the next several years. Second, because of the computational capability we brought to bear, a new way of doing software has emerged, generative AI, which is going to create new infrastructure dedicated to doing one thing and one thing only. Not for multi-user data centers, but AI generators. These AI generation will create incredibly valuable software. A new industrial revolution. Second, the computer of this revolution, the computer of this generation, generative AI, trillion parameters, Blackwell, insane amounts of computing. Third, I'm trying to concentrate. Good job. Third, new computer creates new types of software. New type of software should be distributed in a new way so that it can, on the one hand, be an endpoint in the cloud and easy to use, but still allow you to take it with you because it is your intelligence. Your intelligence should be packaged up in a way that allows you to take it with you. We call them NIMs. And third, these NIMs are going to help you create a new type of application for the future. Not one that you wrote completely from scratch, but you're going to integrate them like teams. Create these applications. We have a fantastic capability between NIMs, the AI technology, the tools, NeMo, and the infrastructure, DGX Cloud, in our AI Foundry to help you create proprietary applications, proprietary chatbots. And then lastly, everything that moves in the future will be robotic. You're not going to be the only one. And these robotic systems, whether they are humanoid, AMRs, self-driving cars, forklifts, manipulating arms, they will all need one thing. Giant stadiums, warehouses, factories. There can be factories that are robotic, orchestrating factories, manufacturing lines that are robotics, building cars that are robotics. These systems all need one thing. They need a platform, a digital platform, a digital twin platform, and we call that Omniverse, the operating system of the robotics world. These are the 5 things that we talked about today. What does NVIDIA look like? What does NVIDIA look like? When we talk about GPUs, there's a very different image that I have when people ask me about GPUs, is Blackwell. And this, to me, is what a GPU looks like in my mind.